So in the third episode, we are going to deal with some complex logic that we need to write. We're gonna need to add some more attributes and methods so that it will be helpful to extend the game and really to see the expected behavior of the Minesweeper game. So this episode and the next episode is going to be titled Minesweeper Algorithms because we are going to write a lot of things that will calculate stuff. So we will really start seeing the expected Minesweeper game going on. So before we get started, if you enjoyed until this point in this series, please be sure to hit the like button on that video and as well as subscribe to my channel so you will never miss an upload. Let's get started. Alright, so in that episode we are going to focus a lot in our cell class because we're gonna need to write some logic to prepare the Minesweeper game. That's going to be very fun to write all of those new attributes that we'd like to receive in this cell class, and as well as writing all the methods that will be responsible to write the logic of our Minesweeper game. So there's going to be a lot of object-oriented stuff that we're going to write in that episode, and that's going to be very cool doing all of those. Alright, so first things first, we might want to start by increasing the size of our buttons to make them more readable, and that is achievable by going ahead to the instantiation of our button class inside this createButton object and passing in some additional arguments that will be responsible to really increase the size of our buttons. Now, before preparing the project, I figured out that passing in width equals to 12 and height equals to 4 are great values when you play Minesweeper where it has 36 cells. Now you can actually go ahead and pass in here some formula that will be responsible to make the buttons smaller if the grid size gets bigger. But in order to make that simple, then I'm just going to leave it as it is, and I'm going to assume throughout the tutorial that we are only going to play the Minesweeper game with 36 buttons, meaning the grid size being 6, which is that value that I am talking about. So now I'm going to execute my main file, and that's how it looks like right now, and that's just bigger and more readable and more comfortable to play with. Alright, so now that we came up with this, then we're gonna need to take our next steps in order to have some more info about each of our cells. Now, for example, we don't have even one single indicator about which cell is what until now, because the only thing that we know about each of our cells is the fact that it is just writing a text in all of those 36 buttons. But it could have been great if we could have some indicators about each of our cells in here. So for example, until this point, we know that we have 36 buttons. So we have those and we have those, right? But we don't have even one single indicator about each cell. So for example, it could have been nice if this cell, for example, could have an attribute like x equals to 0 and y equals to 0, because that is just something that represents that cell specifically. That means that we could receive some more attributes in that cell. And the same goes, for example, for that cell here, right? It could have been great if we could say that this cell had an attribute like x equals to 5 and y equals to 5. And the reason I use this 5 and 5 in here is because we start to count from 0. So 0, 1, 2, 3, 4, 5, and the same counting method from the top to bottom like that. So let's go ahead and receive some more attributes in this class. So I'm going to go to my init method and I'm going to say x and y like that, and make sure that you add those commas, and then I'm going to use the self assignment self.x equals to x. Then I'm going to do the same for self.y. Self.y is equal to y like that. And now that I have this, then I can actually go ahead and go to my main.py file and pass in those numbers, because I iterate over those numbers when I create those cells. So you can already see that we have some problems instantiating the cell because we need to pass in some mandatory arguments, and once we do that, then we are totally fine. And now that we have some attributes in each of our cells, we can actually use those to temporarily display a different text on our cells. So we can change this into a formatted string, for example, and we can use the reference to self.x, comma, self.y inside the curly brackets. And now I can execute our game, and you can see that now we have some attributes where each attribute represents a unique cell, right? So we know that x equals to 5, y equals to 5 is that cell here. And we know that 2.2 is that cell over there. So that's a great starting to prepare the algorithm that we want to write to have the Minesweeper game. Alright, so now that we have done this, then we want to prepare designing, creating some mines between all of those cells. Now we know that in a Minesweeper game, when we start each game, the game picks up some random cells and it converts them into cells that are forbidden to click, meaning mines. So we need to somehow write an algorithm that will be responsible to take a couple of cells and turn them into mines. Now we know that we already have an attribute that is called isMine, and by default all of those are false. So now we're gonna need to write a method that will pick up some cell objects and will convert those attributes from being isMine equals to false to isMine equals to true, so that we will have a great beginning of the Minesweeper game going on. Now we know that temporarily all of the cells are not mines because we always assign false, but that's something that we are going to change just right now. So in order to start designing this, then it's a great idea to have a static method which we can call from the main.py file right after we instantiate the cell objects. So it's a great idea to just have a method that is not belong to each instance, besides it is belonged globally to the class. And that's the definition of a static method. So I'm going to use that decorator of static method, and I'm going to say def randomize mines like that. So this means that it takes a couple of cells and turns them into mines. So that is exactly where we'd like to write some logic to turn some cells into mines. So temporarily I'm going to pass in pass so we will not have any errors. And now let's see how we are going to do that. Alright, so first things first, we need to understand how we can store all of our instances inside a list. And there's a great reason that we want to do that in that stage, because we instantiate 36 instances, but we don't have any control how we can take further actions with those 36 instances that we instantiate from this cell class that we have here. So in order to have a collection of all of our instances in one place, then it is a great idea to create a class attribute inside our cell class, which we can name something like all. And that's gonna be an empty list temporarily. Now we're gonna append the objects of the cell class to that all variable. And that's something that we can do dynamically inside our init method, because this method is the method that is being called every time that you create an instance. So it totally makes sense to go ahead and do here something that will be responsible to append the object to the cell.all list, so we can have all the instances of this cell class in one place. And that means that we're gonna need to say here cell dot all. Now that's the way that you can access class attributes inside your class. You might have thought about using just all, but when we work with classes, you always need to specify the class name as a prefix when you access your class attributes. So we can say cell.all.append, and then we could add the object itself, which is self. So now that we have done this, then we probably like to test if that is something that's going to work. So we can go to our main.py file, and right after we instantiate all of those objects in those lines, we can say print cell.all. So we should see a list with 36 elements inside this console here. So you can see that this is exactly the result. You see that we have probably 36 elements in here. That also we can test with using the len built-in function. Before that, you can see that we have 36. Now you probably noticed that the objects, the way that the objects were represented in the console was not too much friendly. It could have been great if we could override this setting, that we could see the objects nicer and more friendly, and that's something that we can do by overriding some magic methods. So we can go to that cell class and we can override some magic method that will be responsible to change the way that the object is being represented. And I'm talking about a magic method that is called REPR, like that. So we can go ahead and say that this should return a formatted string that could look like the following: cell, and then we will pass in here self.x and self.y. So that's just more friendly string that will represent each object more friendly. So besides seeing random IDs, then we can see real friendly names for each of our objects. And if we want to test that this is going to work, I can again allow myself to execute this main.py file and confirm that, and you can see that now I have way more friendly objects in here. You can see that we have perfect result. Alright, so now that we understood this, then I want to work side by side. Left side will be the main.py file and the right side will be the cell.py file. Now I want to check out each time that I'm doing a great job in writing some logic inside this randomized mines. So I'm going to go ahead and right after I instantiate those, I'm going to call this randomized mines static method. So I'm going to say cell.randomize mines, like that. And I'm going to leave it as it is, and every time that I add a piece of code inside this method, then I want to execute the entire game to see that I did not screw up anything. Alright, so first things first, in order to randomize things, in order to pick some random things from a collection, we need to work with the library that is called random. So I'm going to go to the first line here, to the second line, and I'm going to say here import random. Now, random has a very specific method that is responsible to pick randomly some elements from the given collection. Now, I'm going to show simpler example at first. So, I'm going to go here and say that I have a list. And again, that's going to be just a simple example to show you how that method I'm talking about works. So I'm going to have a list with 3 names, alright? Going to have Jim, Michael, and Paul. And then let's say that I want to randomly pick 2 names each time. So I'm going to go ahead and say random.sample. Sample is a method that at first accepts the collection that you want to pick randomly elements from, so it will be my list, and then the second argument is the amount of elements that you want to pick each time. So since I want to pick 2 names each time, then I'm going to pass in here 2. So let's also assign this entire statement to a variable. So I'm going to call this picked names, right? And then I'm going to just print it. So print picked names. Now pay attention that I call this method, so we should be seeing the results when I execute this game. So when I go ahead and execute our program, then you can see that I receive Jim and Michael. And for our next run, we can totally receive different names. You can see that this time I received Jim and Paul. So that's exactly what we want to do with our mines. We want to randomly pick some cells, some cell objects, and then just change the attribute of isMine to true, because all of them are false. So now that we understood this, let's go ahead and write the needed logic inside the randomized mines. So my list is going to be cell.all, because that is the collection that I want to pick some objects randomly from it, right? So I'm going to delete this line right after we understood how the sample works. I'm going to change this variable to picked cells, because that is just a more realistic variable name. And then I'm going to delete this line temporarily. I'm going to jump a line here so it will be easier to see the arguments that are passed. And the collection that I will be passing here will be cell.all, because the cell.all includes all the instances, right? And then we need to decide for an integer which will be responsible to be the element count that should be picked. Now, if we have about 36 cells, then it might be a great idea to pick at least as a quarter of a value of it. So maybe 9 cells to convert them into a mine will not make this game too much difficult to basically win it, right? So I'm going to pass in here 9 temporarily just to see how that is going to work. Then I'm going to say print picked cells and execute our program. And then you can see that we have randomly 9 cell objects that have been picked in here. So that's an extremely useful method that we can go ahead and use it to pick up some cells and convert them into mines. So now that we have a picked cells collection, meaning a picked cells list, then we can actually iterate over the picked cells objects and only changing the attribute of isMine from false to true. So let's go ahead and besides printing picked cells, use a for loop that will look like the following. So I can say for picked cell in picked cells, and then now I'm iterating over each object. So I can say picked cell dot is underscore mine equals to true. Now the isMine is coming from here because we already know that we have such an attribute and we just want to change that to true. And now that we have this, then let's go ahead and run our program, and we should not be seeing anything, but in the background the attribute has been totally overridden by the value of true. Now if you really want to test that, you can go ahead and after calling the randomized mines in the left side, you can go ahead and use something like for c in cell.all, then print the c dot is mine. So we should be seeing some trues, some falses, and that's going to be the final testing that will really show us that we were able to change some attributes. And you can see that this is exactly the result. So we have done a great job picking up some random objects and just turn them into mines. And that's just a one way that you can do that. Okay, so now that we have done this, then it totally makes sense to delete those sort of debug lines. Now we need to figure out how we are going to be dynamic deciding the value of this picked mines amount, right? So we can go ahead and use the settings.py file to actually use some formula to calculate how many mines we want in our game. So we can go ahead and use here one more setting that we can name mines count, and that might be equal to something like the following. So I will open up the parentheses and I will say between those grid size power of 2, and then I can divide it by 4, because in that game currently we have 36 cells because we iterate over the value of 6 2 times. So it makes sense that we write such a formula, right? So 6 power of 2 divided by 4 is 9, and that is pretty much the value that we look to have when we want to have at least a fair Minesweeper game. We don't want to have half of the value, we don't want to have like 27 mines, because that is just going to be too difficult to win that game. So about a quarter of that value is just fine. Now you might also ask yourself what is going to happen if one day I will change the grid size to 7. So 7 power of 2 is 49 and divided by 4 is 12.25, and that is just not good because mines count should be an integer. So I'm just going to add here one more forced slash, and when you use double forced slash, it is forcing it to be in an integer. It totally ignores the remainder. So we can just add here one more forced slash, and that will be okay. And now I can go back to my cell.py file and I can refer to that value, settings.mines count. And I see that we don't have any import line about the settings, so I can just go ahead and use import settings up top and we should be fine. Alright, so that will be it about this episode. In the next episode, we are also going to take further actions in the cell class, which will be responsible to have some nicer visualizations when we click on our mines, and as well as there are going to be some more methods that we need to write in order to be aware of the situation of the game. For example, if we click on a cell, then we want to be aware how many mines we have around that cell that has been clicked, right? So it's going to be a lot of code that we should be writing in the future episodes, which is going to be extremely fun. So as usual, if you enjoyed in that video, please be sure to hit the like button and as well as subscribe to my channel, and I will see you in the fourth episode.